Here it is, that glorious moment where you begin programming. If you've never done this before, this is, well, a rite of passage. We're going to create what's called Hello World, and it's the starting point of almost every programming language. I'm going to go through this super slow just because I'm going to assume this is your first time doing this. Before you, we have Qt Creator installed and ready to go. We've already created some very blank Qt and C++ apps just to run them and make sure everything works as expected. If you skip those steps and you hit any issues, rewind and watch the previous videos. Okay, so first things first, we're going to create a new project. And we've done this before. You can either go to File, New, or you can just click this New button on the Welcome tab. I'm going to click New. Make sure you're in Application Qt and go to Qt Console Application. Click Choose. Put it in whatever folder you want and give it a name. So this is Qt6 Core Beginners. This is Lesson 3.1. Feel free to name this whatever you want, but I'm going to use a standard naming convention that lines up with the video. Hit Next. Build system gets a little bit confusing. Other videos and a lot of my historical videos, you've seen me use QMake. We're going to use CMake. Now, you may be wondering what the difference is, and we're going to cover this in later videos, but QMake is Qt's proprietary build system, and in Qt6, they're moving away from that to CMake. They're still going to have and support QMake, but they're no longer going to continue to develop it. So in future versions of Qt, this will start to phase out and eventually go away as they favor CMake. But you can use whatever build system you want. We're going to use CMake. We don't need a translation file because all of these videos will be in English. And then kit selection. You may see other things, but really what you want is desktop Qt 6. Doesn't matter if it's 6.1 or 6.5 or whatever version's out there now. And just ignore this last little bit where it says GCC 64-bit. This tells you the compiler along with the bit level we're compiling. Most modern compilers should be 64-bit. Hit Next, and project management. We're not going to use any source code control, but if you wanted to, you could definitely set it up and use it here. And finish. The IDE is going to do a lot of parsing. You see all those green boxes that popped up here. If you had a red one, that means something bad happened and you need to figure out what it is. That's where Google really becomes your friend. So overall project structure, you have your project and you can collapse this down. Because it's bold, it is the default project, and when we run this, it will run. If we go ahead and run it now, absolutely nothing's going to happen. I mean, it'll show it on the screen, but it doesn't look like it's doing anything. And in the background, it's actually running. It's just running in what's called an application loop, meaning it's sitting there waiting for instructions. Now, again, let's go into project and run. We've covered this in a previous video, but if you can't get the terminal to run, or if you don't want to run it in the terminal, you uncheck that box. You go to Projects, Run, and then uncheck Run in Terminal. Now when you run this, it will run in this application pane. You see we've already got a tab here with our project name. And you could just, if you wanted to, click this green button instead of going over here. Does the same thing, but you notice how it's still popping open a terminal. Why is that? Well, let's jump out of here. Let's save it. So I'm going to hit Control-S on the keyboard, or you can go down and, well, do a save all. Let's run it again. Now notice there is no pop-up window. It's just running right here in the IDE. Doesn't really matter which way you do it, just make sure you understand the difference between the two. I'm going to hit stop. Now, I'm not sure if you noticed, but there's this little guy over here, and if I run this again, it's a green arrow with a bug. It's the same guy here. It's the debug mode. We showed this in a previous video where basically debug is going to go through the application line by line. And when I say line by line, I mean the actual computer code in the background. It's going to line it up to the instructions on the screen. Very slow way of doing it, and it's a little bit more advanced than what we're going to cover. So just as a de facto, I'm going to run these in a terminal so we see that nice actual screen pop up like that. So let's pick this program apart. We've got our project name, we have the cmakelist.txt, and let's crack this open. This is the CMake file. What this does is really tell CMake how to build the application, and a lot of this is going to look like, well, ancient Greek. We're going to play around with this a little bit in future videos, but right now just leave it as the default. Basically what we're doing is we're saying, here's the project, here's the language we're going to use. We're going to use C++ version 11. You can switch this to 17 or even 20, whatever you have installed, but the default on my box is 11. And then we're going to find packages. In case you're wondering what this find package is doing, it's really right here, these CMake modules. You can expand that out. This is Qt. This is actually what we're importing to build this program. So a simple little program has all of these things that we're relying on. That's what I mean by it's not very easy. And well, most programming languages hide the complexity. And with C++, the complexity is right in your face. So I'm just going to collapse that out because we don't really need to deep dive in there. The main takeaway here is add executable. We have an executable name, and you see this main.cpp. What that is our main file. This is the entry point for our application. And when we flip over, here is that file. This is the actual source code. This is C++. Now, if we were to change this file, you see how it's got this little asterisk next to the file name? That means the file has been changed. If I save that, you'll see it's going to parse and rescan it. If there's ever a little red box there, that means something bad happens. So let's go ahead and simulate that. I'm just going to type some garbage in there and hit S. You see, there's a problem. Cannot configure because it can't parse it. And when we see it in here, we can see there's a little parser error, and it's telling us what we did wrong. It's expecting the bracket, and instead it got some weird text. So I'm going to take that out, save it again, and this time it'll have a good parse. Now, back in our main.cpp, let's pick apart this application. We have an include, which is basically C++'s way of saying, go grab this code that someone else wrote, which is in one of these modules, and these are included based off our, you guessed it, cmakelist.txt. It's actually right here in core. So we're grabbing the Qt6 and Qt5 components core, and we're saying it's required to build this. All right, back in our main file here, we're going to use core application. We have int, main, and some arguments. And I don't expect you to understand what any of this stuff is. Just understand when you see this word here, main, this is the entry point of our program. This is where our program's actually going to start running. And then we have some instructions. So we're saying core application, we're creating a variable. We'll talk about variables in another video. Just understand we're creating something. And we're passing some information to it, telling it how to create it. Then we're going to return a.exec. And if all of this seems super confusing, don't worry, we haven't covered it. This is just simply the entry point. Just kind of absorb this like a sponge. Really what we're doing is we're starting our program, we're using code that somebody else written, and we're just going to do something with it. So let's go ahead and let's add in some stuff here. You're going to see me do this from time to time where I'm going to copy off the screen and paste it in. So what are we covering? Hello world. Why? Because this is the starting point in every language. How? Well, we have the main function, the includes, the Qt core app, and exec, CMake and CMake modules. All of these we've covered. Now let's go ahead and add in, I'm going to include Qdebug. Qdebug is, well, a special set of classes that really lets us output to the screen. And we're going to do this the easiest way possible. Qdebug has certain functions that we can call. Now, a function is just a set of computer code that we can run. And we're going to cover these in depth. But right now, we're just going to take a giant leap of faith. I'm going to say qinfo. Hello world. So what we're doing here is we're saying, hey, take this function, this bit of code, and we're going to shove some information into it. And we're going to shove the string hello world. Now you notice this little bracket at the end here, and it's at the end of every single line. That's denoting it's the end of the statement. If we forget that, well, C++ is going to be very unhappy with us. And you can see expecting a semicolon after expression, meaning C++ is smart enough to know that, hey, this is not one expression. it's going to stop reading whenever it sees this semicolon here. So let's go ahead and add that. And now it's smart enough to know that, hey, this is the expression right here. Pretty cool, huh? Now we're going to go ahead and build, and it's down here. It's this little hammer, and you can also just right click and do it, where you can build or run CMake or deploy, so on. So we're just going to build. I'm going to click this little hammer. And what's happening in the background here is, well, the compiler's running. Let's go ahead and clear that out. And I'm going to clean this. And then I'm going to rebuild. And this is the compiler actually compiling. We've talked about this a little bit, where it's going to take our source code here, run some things on it. We're doing a build, and then it's running mock, meaning the meta object compiler, and it's generating those object files based off of our code. Now you notice how there's 2 object files, but there's only 1 code file. So what's happening here is mock, the meta object compiler, is generating this for us. It's all that stuff that happens in the background magically that we don't even know about. And then the code that we wrote is being generated into an object file. And then the linker comes in and links everything into an executable named after our project. Whew, that's a lot to take in, but really it's pretty simple. It's just going to take all of the code, compile it, link it, and, well, create an application that will run. Ta-da! Hello world. Now, if you've got some sort of error message on the screen, chances are either you forgot the semicolon, in which case, let's go ahead and simulate that. So I'm going to try and run this, and you're going to notice it's going to build, and it's going to fail, and it's going to say something like expected semicolon after expression, expected semicolon before return. So it really highlights on the screen what the problem is here. And it even tells you, hey, right here, this little arrow is pointing where the problem is. So we'll just add that in. Or if you just kind of omitted this, see if I can cut that. And now let's give it a good build. Notice how it builds, and it may actually run for us. Sometimes this is included in Qt, sometimes it's not, we have to add it. I got lucky and it's there. I'm gonna go ahead and kill that, clean this, and give it a good rebuild. And I got lucky, it's just gonna work. However, when in doubt, you should include what you need. So this is our program in its entirety, hello world. All this thing does is it just simply displays the text hello world. I wouldn't go as far as saying now you're officially a programmer, but hey, at least you've made a program. Congratulations. Now that we've built a hello world, let's go ahead and look at the build process a little bit more in depth. So I'm going to say new Qt console application. I did say I was going to go through these a little bit faster as we get going through them. Now I'm going to call this, and this is going to be C for CMake. Again, doesn't really matter what you name it, but the build system here I'm going to use is CMake. And then I'm just going to next, make sure you have the right version, and finish. And I am going to just grab some code from off the screen here and plop it in. This is just the hello world that we did in the last video. Again, you may not need this include Qt because it's probably already in Qt Core and Core application, although I have seen on some systems it just simply doesn't work that way. So when in doubt, go ahead and include it. Now, all this is doing is just printing out hello world on the screen. Pretty simple, actually. So I'm going to clear that out. And let's go ahead and give this a good build. Now, we talked about this before. Running steps for a project, whatever the project name is, persisting CMake state, that's just CMake doing some background maintenance, and then it's going to start the actual build process. So we're really calling the application CMake with some parameters, build, and then build target all. Now, automatic mock for UIC, what does this mean? Well, that means that we are going to generate, or I should say Qt is going to generate for us code. That code is actually compiled into this guy right here. moxcompilation.cpp. Let's actually go out and let's look at this right here. Here's our actual source code. You can see we have our cmake.txt, cmakelist.txt.user. This is just user settings for your session. If you open that up, I think it's just an XML file. And then we have our actual source code that we've been working on, which is, well, right here. Now let's jump back out here and you see this build folder. And just for clarification, I'm going to wipe both of these out, move them right to the trash, and let's give this another build. All right, let's jump back here. Here's our build folder, and you can see we have other things going on here. For example, autogen. What is all of this? Well, this is source code that Qt has generated for us. And you see it starts with MOC, which is short for mock or meta object compiler. What's happening here is Qt is adding a bunch of code for us, which makes our life a lot easier in the future. But right now, we're still in the infancy steps, so we won't really understand it even if we looked at it. However, if you're super brave and you just wanted to see what's going on here, you'll see, oh, this file is auto-generated. Changes will be overwritten. No files found that require mock. Meaning, because our program's so simple, it doesn't really need mock. That's how smart Qt is. It's not going to just put a bunch of garbage in there because it doesn't need it. That's actually incredibly cool. All right, so that in a nutshell is the CMake build process. So let's go out here and let's collapse this, close that. And let's go new project. I want to make a Qt console application. And let's call this Qt6 Core for Beginners. This is 3-2, and we're going to say Q, because we're going to use Qmake, the older build system. Again, doesn't really matter what you name it. The big takeaway here is when you get to build system, this time go to Qmake. No translation file. Kit's going to be the same kit that we used for the other project. And finish. Now you'll notice this looks drastically different, and most of the tutorials out on the internet, including my own YouTube channel, are going to look like this. It looks much, much simpler, although there is a bit more complexity. We have this .pro file, which stands for project, which has, well, the Qmake way of doing it, which is drastically different than CMake. At its core, really it's doing basically the same thing. We're telling it what not to include, what source code files, and then our specific deployment targets and what we need. And this gets vastly more complex. Again, our application is pretty simple. I'm just going to save this. And let's go ahead and take the same code. And actually, just so there's no discrepancy here, I'm going to just select all. And let's go ahead and copy. And I'm going to go out here and I'm going to select all. And let's go ahead and paste. The literally exact same code, every little last bit of it. Let's go over here, let's clear this out, and notice this is bold, so this is the one that's going to build. And whoa, that is a drastically different build process. You can see it's much, much different. So we're running steps to build the project, and then it's starting, and then this time it is running a different program altogether. It's running Qmake, not CMake. So at the end of the day, really, it's just which program you want to run, and then you have to tell the program to run a specific way. It's creating a stash file, something we really don't need to know about, but basic settings for Qmake, and then it is going to go ahead and build it out. But the same basic principle applies. It's going to build out, call mock, and do all these things in the background for us. And when we go out and we look, we've got our C and our Q. So there's our CMake, and here is our Qmake. It looks drastically different. At the end of the day, we have a binary executable that we can run if we need to. This is incredibly cool. So you may be scratching your head going, now wait a minute. If Qmake exists and Qmake is, well, just there, why are they switching to CMake? Over time, CMake has become the industry standard, and I'll just say it. Some of this technology may not have existed back when Qt was created, or it existed and just wasn't up to speed, so Qt actually created their own. But as the technology advances, instead of having to maintain this thing, Qt wants to realign with industry standards. So I'm going to right-click and set this one as the active. And let's clear this out. And we've done this before. No work to do because we've already built. Let's go ahead and clean this, which is going to get rid of all those object files. And then let's rebuild it. Same thing. It's going to call mock. Mock's going to figure out if there's anything we need to do. It's going to compile our code and link it. So at the end of the day, it doesn't really matter which build system you use. They both pretty much do the same thing, just slightly different ways. And when I say slightly, it's under the hood, it's drastically different. I'm very well of that, but I'm trying to overly simplify this when it comes down to build systems. This is probably the only time in this series you're going to see Qmake, because we are going to favor CMake, because that's what Qt's going to be using moving forward. Okay, let's take a look at comments. So let's go ahead and make a new project here. We're going to call this, let's see, Qt6 Core for Beginners. This is 3.3. And let's go ahead and hit next. We're going to switch that system over to CMake. We want to use that as de facto. No translation file needed. Same kit we've been using. Again, we're going to whip through this fairly quickly because there's no sense in reinventing the wheel here. All right, so what is a comment? At the end of the day, what do comments actually do? Well, they're for you, the developer, and other developers. I'm actually just going to paste some in. What? Comments. Why? Notes for you and other programmers. How? Well, we've been using them this whole time. You notice how we have this little chunk right here. But when we run our program at the speed of my little virtual machine here, there it goes, it just runs. But what happens if we take these special symbols out? Go ahead and save that. Notice how suddenly the IDE gets very, very angry. It's got all these, hey, what are you doing kind of things. If we try to run this, it's just not going to go. Why? Because those are not valid computer commands. And this is what I mean by in C++, you can just have some crazy error messages. Null pointer underscore T, this is not a member of STD. What? What are you even talking about? And then if you click on it, it takes you to this weird thing. You may be scratching your head, and rightly so, because it makes absolutely no sense until you think like the computer. Under the hood, what's happening here is the computer's trying to figure out what this is and convert it into some sort of computer code. This is not computer code. These are comments. We want these specifically for us. So it starts with a slash, and if we put a star, notice how everything suddenly turns green, and I'm going to just close that. Everything magically turns green. In case you missed it, go slash star. So what we're doing is we're telling C++ that, hey, we want a comment that spans multiple lines. Now we need to tell it when to stop. So I'm going to say, hey, star slash. Now it's just within this range. There's a matter of style, and we'll talk about coding standards and conventions in the next video. However, just understand that some people do it this way. And as you hit the return key, it puts another star, and you can just simply backspace and slash, and then there's the end of your comment. So this would be, this would be a comment, and this would be a comment. They're two separate comments. The whole point of a comment is for you, the developer, to put notes that the compiler does not try to convert into computer code. It's a good way for you to say, hey, what the heck am I doing? So let's go ahead, and I'm going to put in debug. Don't really need it because it's already baked into Qt, but just in case somebody's computer out there doesn't have that the way, again, Qt runs everywhere, so you may run into little gotchas, or if somebody tries to run this on an older version of Qt, want to make sure that's in there just in case. I'm going to say Qt info, and we're going to say hello world. Again, not super complex at all. And if we run this, what's going on here? Well, we're making our hello world. It's going to print hello world out. We've done this before, but now watch what happens if I say slash slash. Notice how this is green. In our IDE, we have it configured by default, which is green or comments. Now, people get a little concerned because they see this is green. Those are not comments. These are includes. Very different. When you see something that starts with a slash, understand what you're doing. You're making a comment. And if we run this now, that is no longer going to execute. There's no hello world. We can delete those, rerun it, and then magically hello world returns. Ta-da! There it is. You can also go in and select stuff, right click, and then toggle comment selection. This is a good way of turning big chunks of code on or off, and it does this same thing. Just wanted to throw that out there. All right, so let's go ahead and do that. Now, that was how we would turn code on or off. Let's say I just wanted to say a comment for me, the developer. At times, you'll see me type out a comment or copy and paste one out just to kind of clarify when somebody reads this code what we're supposed to be doing. Now remember, comment will not get executed as code, so this is just a statement. The compiler won't even see that, won't even care about it. See? Hello world. But now I can look at this code and see exactly what's going on. Now there's different ways of doing comments that we've alluded to. So, for example, let's make a multi-line comment here. Same thing, we can make a multi-line comment. Basically, if you see 2 slashes, it's a single line. If you see a slash and a star, it's a multi-line, and it'll keep going until you see that second slash. Works as expected. Now, I want to put in, and for this, I am going to just copy and paste it here. There are different styles of comments, and you'll see these all over the internet. For example, we can do what's called a documentation or self-documenting code. Notice how this is slash star exclamation mark. So what we're doing is we're saying, hey, this is a special type of comment. And this is typical of a program called Doxygen, where you can add all this special markup and you have to read the Doxygen technical reference to really understand what's going on. But we can now create self-documenting code, meaning all of this looks confusing, but when we run it, the compiler doesn't care because it's a comment. It's not processed by the computer or the compiler. But if we run Doxygen, a third-party library or actually application here, it's going to read this text file, look for this and go, oh, okay, I see what's going on. So this is a documentation string, and this is the brief of it. This is a parameter called argument C. And when I say brief, this is the main function. And then it's going to return an integer, things that we just simply haven't talked about yet. But at its core, what we're doing is we're creating self-documenting code. We won't use a whole lot of this just because it gets so verbose on the screen, but I want you to be aware that it exists. This video is more of a video note. I wanted to take a moment and talk about coding standards, styles, and conventions. So what are we talking about? Well, coding standards, styles, and conventions. Why? Everybody does things a little bit differently. Really what they do is they get everyone doing code the same way. And what I mean by this, have you ever cleaned the house and then watch someone else clean literally the same house? You notice you do it 2 different ways. You may start with vacuuming, where your children start with the dishes and your spouse starts with, washing the windows. Everybody does it slightly differently. So really what a coding standard or a convention does is just getting everyone doing it the same way. This is pretty popular where companies will mandate a coding style or convention. So how? How do you do this? Well, it's challenging because there are so many. And let's just pop open Google and take a look here. So we're going to go here and we're going to say, see, let's see. It always interests me what they pop up with automatically. I have no idea. This is just a virtual machine, and for whatever reason, it thinks I need to know about the NBA. Anyway, so we're going to say C++ coding standards. All right, so just C++ coding standards brought up a lot of results. That's just how many people have an opinion out there. So which opinion is right for you? Well, it depends on what you want. A lot of people stick with their company, or they'll go with the brutal C++ coding standards. So like, what are some good coding standards? Notice how it doesn't say what is the best coding standard. It says what are some good ones. And it talks about coding guidelines and standards and things. Really what we're talking about here is how you type your code. Literally, that's what we're talking about. Do you name a dog dog, or do you name it underscore dog or uppercase dog or lowercase dog or upper and lowercase dog? That's really what we're talking about here. So a lot of people will get really spun up about coding standards and conventions. And I wanted to put a real quick video note here that we're not going to follow any one specific standard, style, or convention. And sometimes that bothers people, but I wanted to show there's different ways of doing things. And again, simply going out to Google and looking it up, you're going to find, well, a lot of people have a lot of different opinions about how this should be done. So for example, you can say C++ coding standards for Apple computers. You'll see that Apple has their own coding standard. What about Microsoft? Microsoft has its own coding standard. What about Google? Again, Google has their own coding standard. So every single company now has kind of created their own version and their own way of doing things. So I don't want you to get too hung up on any one style or standard. Everyone's going to do things a little bit differently, and every company is going to have their own style and mandate. You may see people actually comment in these videos, well, you're doing it wrong because you're not following some coding standard, style, or convention, or you should have used camel case or, this other case or the style or this or that. At the end of the day, it simply doesn't matter. I'm going to repeat that just for effect. It simply doesn't matter because the compiler does not care what kind of coding standard or style you used. This is simply for you, the developer, and other developers to agree upon a certain way of writing the code. In the very end of it, the compiler and linker simply do not care.